So both like MOSFETs and BJTs, like bijunctional transistor, right? So a MOSFET, the metal oxide semiconductor field effect transistor, and our transistor, normal transistor, that is BJT, commonly used for our amplifiers and switching devices. But if I come to the difference part, the MOSFETs, especially, these are voltage controlled devices. So like in the BJT, we say it as a current control device. So the whole operation of the BJT depends on the base current IB. Here we say the whole operation of the MOSFET depends on the gate voltage VG. And MOSFETs here are having higher input impedance. Whenever you want to match high any output, right? I mean, like when you want to get a when you want to get loaded to any of the circuitry, so your input impedance of that circuitry should be very high. Because what will happen, for example, you have a battery. So internally it will have some resistance, Ri. So if this input impedance is not high, which is matching with the Ri, it is the internal resistance of the battery. So what will happen? Some voltage will drop across this also, so that your battery will become heat, and you have seen this kind of scenarios, right? Your mobile getting heated. So that is like sometimes maybe like due to large power consumption, or due to impedance imbalance also, right? What will happen? More power will be dissipated across the battery. So that's where we should always have very high input impedance, that which MOSFET provides. And MOSFETs are like less sensitive to your temperature variation, and you can actually easily integrate to your ICs, integrated circuit. So MOSFETs are like of two types. One is D MOSFET, another is E MOSFET. D MOSFET is nothing but depletion MOSFET. And E MOSFET is nothing but enhancement type MOSFET. Coming to E-type MOSFET, we will have P-type substrate, and we will have N channels, and also gate. And here we will have source, gate, and drain. And here overall we will have substrate. On the top of the substrate, they will be building these. So the substrate is of P-type, and we will have N-type channels, and we will have gate region, and along with that, like we will also have some metallic contacts here for connecting the gate, source, and drain. But if you see, it is insulated by insulators, right? In between, it is insulated by insulators. So based on whatever the gate voltage you apply, so some electric field will be created, and we are establishing the channel. Okay.
Yes, sir.
So by default, in the depletion type, no, first we are talking about enhancement type. So this is enhancement. So in an enhancement type MOSFET, so by default there won't be any channel. So as you apply this voltage or field, the channel is going to be established. So due to this channel, so this drain to source current starts flowing. Right? So that is the functionality of enhancement type uh, MOSFET. So when like gate to source VGS is 0, the channel is absent. The VGS is greater than 0. So some channel is going to form. As the VGS keeps increasing, so concentration near that Si2 layer, right, the gate layer, it keeps increasing. So that the flow between gate to source also increases. So at certain point, the flow ID, so the gate current what I am saying, which is flowing, the ID, it increases significantly. So as you increase VGS, right, if you see the plot, as you increase VGS, slowly it starts increasing and suddenly it shoots up, this ID. So that point we call it as threshold point. Okay.
Yes.
After threshold point, if you increase also, right, it is not going to change. I mean, it will be same. So there is another plot actually. For various gate voltage, right? As we increase the VGS, so your ID, this is V drain to source. As you keep increasing, this goes to certain point and it will remain same. Goes to certain point, remains same. So these are various VGS points. So for example, VGS here it will be 8 volt. Here VGS will be 7. So VGS will be 3 volts, so on. So for various VGS, it will increase to certain point and it will be stabilized. So for determining the ID, right, the current, we have a relation K into VGS, gate to source voltage, what you have applied, minus VT whole square. And VT is the threshold voltage for a given MOSFET. And K is given by equation ID on divided by VGS minus VT whole square. Same way it will be discussed for enhancement depletion also. In depletion, right, what will happen? This channel already it will be established. So you're breaking the channel. Okay. So you're breaking the channel in the depletion type MOSFET. Okay.
Yes.